Today we are going to talk about the risk management of smart city construction. Basic concepts of risk management in smart city construction. Risk, the combination of the likelihood of an accident and its potential losses is called risks. Any losses or adverse consequences that are contrary to expected benefits are potential losses, or losses or adverse consequences caused by various uncertainties to the participants in the engineering construction, are also considered engineering risks. Risk management. This is the process of the project in which all parties involved in the project, including the owner, survey and consulting units, design units, construction units, supervision units, monitoring units, etc. By defining risks, identifying risks, analyzing risks, evaluating risks, and controlling risks, we aim to optimize the combination of various risk management techniques and carry out effective risk control and proper follow-up treatment throughout the entire process of project implementation. Risk definition. The process of establishing engineering, risk management grading standards, and dividing risk assessment units. Risk identification. The process of identifying the types of potential risks, accident locations, times, and causes in engineering construction, and systematically screening and categorizing them. Risk analysis. It includes risk identification and risks. That is the process of understanding the nature of risk occurrence and using qualitative or quantitative methods to express the results of risk analysis. Risk evaluation. According to the formulated engineering risk classification standards and acceptance criteria, it refers to the process of grading analysis, hazard assessment, and risk ranking of engineering risks. Risk control. Measures taken to reduce the risk of losses in engineering projects, such as strategies, technical solutions, or measures. The following principles should be followed in the allocation of responsibility for project risk management. The responsibilities, rights, and interests of all parties involved in the construction of the project are equal, mutually beneficial, and balanced. The distribution of responsibilities, rights, and interests should be matched with the objectives and characteristics of the project. Starting from the overall benefit of the project, the responsibilities, rights, and interests formulated should mobilize the enthusiasm of all parties involved in the project construction to the greatest extent. The construction unit shall bear the responsibility for the supervision and decision-making of project risk management. In different stages of project construction, the project construction executive party is responsible for the implementation of risk management and bears the corresponding responsibilities stipulated in the contract for the risks during the project construction period. Risk management of smart city construction. The water pipeline of the rainwater reuse system is strictly forbidden to be connected with the domestic drinking water pipeline. In areas with high groundwater level and serious runoff pollution, effective measures should be taken to prevent rainwater from infiltrating rainwater from polluting groundwater. It is strictly forbidden to dump garbage, domestic sewage, and industrial wastewater into rainwater collection outlets and low-impact development rainwater facilities. And it is forbidden to connect the open sewage pipe network to low-impact development facilities. Warning signs and alarm systems should be set up in urban rainwater drainage channels, waterlogged prone roads, sunken overpass areas and other areas, as well as large-scale low-impact development facilities, such as wet ponds and rainwater wetlands. In urban green spaces and emergency facilities and full-time management, personnel should be equipped to ensure the safe evacuation of personnel during heavy rains and avoid the occurrence of safety accidents. Dangerous places prone to steep slope collapse and landslide disasters, places that cause harm to the living environment and the natural environment, and other places with potential safety hazards should not be built. With low-impact development facilities, serious pollution source area, chemical plants, pharmaceutical plants, metal smelting and processing plants, infectious disease hospitals, oil and gas depots, gas stations, etc., which are prone to accumulate pollutants on the ground, and water source protection areas. In addition to the application of this guide, environmental impact assessment should also be carried out to avoid pollution of groundwater and water sources. The following risks should be taken into account during the operation of low-impact development stormwater facilities: whether the green roof is causing the roof to leak, whether infiltration facilities such as bioretention facilities, seepage wells, seepage pipes, channels, and infiltration ponds cause the collapse of buildings or structures on the ground or in the vicinity, or cause water leakage in the basement, etc. In order to reduce the risk of smart city construction, it is necessary to formulate more scientific, reasonable, and effective policies, including strengthening planning and design, raising technical level, improving economic policies, strengthening social management, and strengthening policy support. Develop strategies and methods to reduce or transfer risk, including risk aversion, mitigation, transfer, and retention. Research and comply with relevant policies and regulations to ensure that the project complies with local and national norms. Develop detailed planning and design guidelines to ensure that the project meets functional requirements and mitigates potential risks. Implement strict construction quality management to ensure that the project is carried out as planned and meets the expected standards.